Hello everyone. Today's lesson is on graphing exponential functions in the form f of x equals a times b to the x minus h power plus k. Some of the topics we're going to go over today is how to shift and transform the functions. So we're going to address some of these notes in a little bit. Then I'm going to show you how to graph them using a table of values. This lesson will be supplemented by desmos.com. All right. So we're going to start off with a basic function. We'll call it y equals 2 to the x power. So 2 would imply that you're doubling your x values. So that also means if you're doubling, you're increasing by 100%. So that gives you growth. So if my value of b is 2, which I already showed you, if it increases, you see the growth gets steeper the higher the value of b. Okay, which makes sense. The lower the value of b, the growth is more gradual, as indicated here. When b is less than 1, it actually becomes decay. So 0.8 means you're taking 80% of the value each time. You go down to 0.2, it's a more steep decay. Okay, so when b is below 1, it's decay. When it's above 1, it's growth. So let's put this back at 2. Your value of k has to deal with shifting. So if I put k as 3, it shifts the y coordinate 3 units, 1, 2, 3. If I put k as a negative value, say -1, it shifts, -2, it shifts the y coordinate 2 units down. So positive k shift upward vertically, negative k shift downward vertically. We're going to go to the h value next. The h value is a little more confusing because it's the opposite. So let's say we have h equals 1. So if you plugged it in the formula, it might say x minus 1. So notice x minus 1 implies 1 unit to the right. If I put it at 2, x minus 2 implies 2 units to the right. If we have an h value that's negative, say -2, it means to the left. However, the formula would say x minus -2, so you actually would see x plus 2. So this will become more clear when I do another example. So if it says x plus 2, you go 2 units to the left. Okay, the value of a is a little confusing. Basically, a has to deal with how soon or delayed the growth occurs. So if a is kind of a bigger number, it accelerates that growth sooner because it multiplies by the growth factor. If a is exactly at 1, it doesn't alter anything because 1 times whatever is still whatever. If a is smaller than 1 but bigger than 0, it kind of delays the growth. But what's important, if a is a negative value, it flips the curve over the x-axis or over the asymptote for this particular problem. All right, so let's summarize what I just talked about. So the value of k, the constant on the end, does vertical shift, positive k up, negative k down. H is the confusing one. It produces a horizontal shift. If it says minus a number in the formula, that means you go to the right that many units, plus a number, you go to the left that many units. So it's the backwards. So we addressed that and that. B greater than 1 is growth. B less than 1 is decay. That was also evident in my explanation. A is a little confusing, as I said. I explain it as how soon or delayed the growth or decay will occur. And also importantly, a less than 0 flips the graph upside down upon whatever the asymptote is. Speaking of asymptotes, an asymptote is an imaginary line that a function approaches but never touches. For exponential, the asymptote is y equals k. So I'll showcase that quickly, and then I'll do a few specific examples. So say if we put a back to 1, because that's kind of the easiest way to look at this. The asymptote would be the line y equals 0. Okay, so this red curve, it very closely appears to touch the blue line, but it never touches it. Okay, so if k was 0, as indicated here, that constant of 0 means the asymptote is y equals 0. The graph approaches it, but never touches it. On the other hand, if k was 1, my asymptote gets shifted up and would be y equals 1. Okay, so the asymptote is related to the value of k. So let's look at a couple examples on how to graph using a table, and we'll relate it to Desmos. So let's clear this out. So let's look at the problem y equals 3 to the x minus 2 plus 1. So plus 1 implies a vertical shift up 1 unit and a horizontal shift 2 units to the right. That may be easier to see if you compare it to this parent function here. Okay, so quite literally, we have shifted up 1 unit and 2 units to the right. So this would be up 1. Let me just adjust the scale better. Be easier to see. So if this is at 1 here, if we shift it up 1 and then 2 units to the right, it's very evident that the shift worked out. All right, so that would be 2, 2. So let's talk about how to make this with a table of values. So I'm going to kind of write on the screen and share that with you guys. So anytime you're making a table, you would pick x values that are suitable and work well, and then calculate the y values based on the function. So what x values would work well? We're going to choose x equals 2 and also x equals 3. So if you plug in 2 to the function, 2 minus 2 and plus 1, remember to use PEMDAS whenever evaluating. So 3 to the 2 minus 2 is 3 to the 0 power. Anything to the 0 power is 1. So 1 plus 1 is 2. So that point would be showcased here. So that works out. And then if you plug in 3 for x, you get 3 to the first power, which is 3 plus 1 would be 4. So 3 comma 4 would also work out. All right. So those were smart x values to choose. Okay. So keep that in mind. Also, your asymptote would be the equation y equals 1, which, as I said before, it's related to the k value. So this red exponential curve never actually touches this blue line that I'm drawing on the screen. So that line would be y equals 0. All right. So that's an example of exponential growth using a table. You could do more values to produce more values to the curve. But if you know that it's a growth in the asymptote, you can kind of trace it out as I'm doing here. All right, so let's do another example. Next example will be y equals 3 times 1/2. So this is a decay raised to the x plus 4 power. And I'll put a plus 2 after that. So I'm actually going to show you a table here. So I'll copy, convert this to a table, kind of showcase a few things. So I'll add in a few more x values. So we'll do -5, -4, -3, -2. Notice that some of the x values, such as these two, produce integer y values. These x values give you decimal y values, which are harder to graph if you're doing it by hand on paper. So I'm going to screenshot this and then do the table by hand. All right. So again, pick x values that are suitable and produce integer y values. So notice these two x values worked well. So -5 as well as -4. So use the function 3 times 1/2 to the -5 plus 4 plus 2. So that gives you 3 to the 1/2 raised to the -1 plus 2. Anytime you have a negative exponent, you flip this. So 1/2 becomes 2/1 to the first power. So 2 times 3 is 6, plus 2 is 8. So -5 comma 8 would be somewhere up here. And then -4 will work out over here. -4 plus 4 plus 2. That would give you 3 times 1/2 to the 0 power plus 2. Anything to the 0 is 1. Again, use PEMDAS. So this would evaluate to 5, which again is matching the answers in the table. So -4, 5 would be right here. Okay. So you could pick more x values, but you will need a calculator or be good at working with fractions. And then that would produce your decay curve. And then it levels out at the asymptote. Okay, the asymptote would be y equals 2 is an imaginary line that the graph approaches but never touches. Okay, so that's how that works. So that's just a sample of graphing exponential functions. Thank you for listening. I hope you learned a lot today.